Today we're going to continue solving quadratic equations. We're going to do them by taking square roots today. So one thing that we need to recall when we're solving equations by taking square roots is actually how to deal with square roots. So we're going to review simplifying radicals. So when you simplify radicals, this one is a square root of 196. We're going to be dealing with all just square roots today. Try to take the square root of 196, so that means you want to think of a number that when you multiply it times itself, you get 196. Of course, you can just punch this in your calculator to find out if you need to, if you're not great at your perfect squares. If you punch out in your calculator, you'll see that the square root of 196 equals 14. So that's what we call a perfect square. So when you can find a number that you multiply times itself, to get the number that you have underneath the square root, which by the way is called the radicand, then you just take the square root. 14 times 14 gives you 196. Therefore, the square root of 196 is 14. They're not all that easy. If you have a number that's not a perfect square, like the number 147, now 147 is definitely not a perfect square, because if you punch it in your calculator and try to take the square root, it'll give you a decimal. So what you want to do is you want to try and find the biggest perfect square that divides into it. So your perfect squares are 2 times 2 gives you 4. 4 is a perfect square. 3 times 3 gives you 9. 9 is a perfect square. And we can go up from there. 16, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11, and so on and so forth. So what you want to do is you want to try and find a number in this list right here, the biggest number in this list that divides evenly into 147. Turns out that 147 is divisible by 49. So 147 can be broken down into the square root of 49, and 49 goes into 147 3 times. If you do 49 times 3, you get the 147. And the reason we want to find a perfect square is because we want to be able to take the square root of that number. So the square root of 49 is 7. And then the square root of 3 is not big enough to be simplified, so it has to stay underneath the radical. So the square root of 147 can be simplified to 7 square roots of 3. So hopefully you recall that concept from Algebra 1. We'll try another one, the square root of 32. So you want to think of the biggest perfect square that divides into 32. I know that 4 goes into 32, but if I do 4 times 8, that's not quite big enough because 8 still has a 4 in it. So you want to think of a bigger perfect square, 16 times 2. So 16 is the biggest perfect square that divides into 32. If you use 4 and 8, it'll be simplified, but it won't be simplified completely. So we want to use this one. Since 16 is my perfect square, I'm going to go ahead and take the square root of 16, which is 4. And then your square root of 2 is not big enough to be simplified, so the 2 has to stay under the radical. Sorry, I'm going to go back to this one. If you're not great at finding your perfect squares, another way you can do these is by using factor trees. So you could take the number 32 and you could break it down to all its prime factors. So since 32 is even, I know I can just start dividing by 2. I can do 2 and 16. 16 is still even, so I can divide by 2 again, get 2 and 8. 8 is still even, so I can go by 2 again. 4 is still even. So I have this down to all prime factors. So all these little leaves, when you do this factorization, these should all be prime numbers. And since we're trying to take the square root of the number, we want to take pairs of numbers. So I have 1 pair of 2's, 2 pair of 2's, And then this 2 that doesn't have a partner has to stay underneath my square root. So basically you can think about it as one pair of 2's turns into one of those numbers outside your square root. So I have one pair of 2's, so I get a 2. I have a second pair of 2's, so I get another 2. And then my square root of 2 has to be tacked on there because this 2 doesn't have a partner, doesn't have anything to pair up with, so you have to leave it underneath the square root. And then finally, you want to go ahead and simplify this on the outside. 2 times 2 will give me 4. And then again, my square root of 2 just has to be attached. So if you're not great at finding the biggest perfect square, you can always do a factor tree. And when you do your factor tree, you want to just do pairs of numbers. If you had a pair of 3's right here, then you would bring 1 3 out. So maybe you had a pair of 3's and a pair of 2's. It would be a 3 times a 2. And then any single numbers that you have that don't have anything to pair up with, those have to stay underneath your square root. Okay, and then this is pretty much simplified. I can take the square root of 4 on this one. Square root of 4 is 2. I can't take the square root of 5. So that's pretty much simplified. The only thing is it's in bad form. We're not supposed to leave a radical in a denominator. So anytime you simplify a problem or you try to take the square root of a fraction, you take the square root of the top, the square root of the bottom, whatever happens, happens. This one turned out that I had a perfect square on top, so the top is nice and the bottom is not so nice. So what you have to do is whatever radical you have in the bottom, you need to multiply that fraction by that radical over itself. It's called rationalizing your denominator. Okay, so when we rationalize our denominator, you take the square root that's in the denominator and you just multiply top and bottom by that square root. 2 times the square root of 5 is just 2 square roots of 5. And the square root of 5 times the square root of 5, that gives me the square root of 25. Well, the square root of 25 is just the number 5. And this is why we do it, is because we started off with an answer that had a radical in the bottom, and now we have an answer that does not have a radical in the bottom. So this right here and this right here, they have the same value. If you punch them in your calculator, you get the same answer. You get the same decimal for it. This is better form because you're not allowed to leave a radical in the denominator. So you always have to rationalize your denominators. Okay, let's try another one. So for this one, I can take the square root of 25. That gives me the number 5. I can't take the square root of 15, nor does it have any perfect square factors. So this just gives me 5 over the square root of 15. So when I go ahead and multiply these, or I'm sorry, when I go ahead and rationalize this denominator, I'm going to multiply the top and bottom by the square root of 15. So in the top, I get 5 square roots of 15 over, whenever you multiply two radicals times each other, these, when you multiply them together, will give you the square root of 225. The square root of 225 is just the number 15. So what happens is when you multiply two identical radicals together, the answer just turns out to be whatever the radicand was. Now this one I can simplify a little bit further because my 5 and my 15 can reduce. So you can cancel off your 5 because 5 goes into 15 3 times. So then your final answer for this one would be the square root of 15 over 3. Now, even though 3 does divide into 15, you can't simplify this because these are two different types of numbers. This 15 is a radicand. It's under a square root. This 3 is not. so they don't match. They're not the same types of numbers. So you cannot simplify them. They would have to either both be under the square root or both be out of a square root. So this is your final answer. Okay, why are we talking about this? Well, because we are going to solve equations by taking square roots, and that's what's going to happen with our answers. We're going to have square roots that we're going to have to simplify. Sometimes we're going to have to rationalize our denominators. So here are your steps for solving equations by taking square roots. You're first going to isolate x squared, or whatever the variable is. You're going to take the square root of both sides, and then just whatever happens, happens. If you have to simplify the radical, you simplify it. If it's a perfect square, you just go ahead and take the square root of it. Okay, the one thing you want to remember though is you're always going to have your answers are going to have plus or minus. Okay, this is very important because we're going to have an x squared, which means we get two answers. It's because we're going to be able to use the positive of the answer or the negative of the answer. Okay, and then your final thing, make sure you simplify all radicals and rationalize all denominators. Here's our first example. Okay, so if you look back, the first step for this is to isolate the variable that's being squared. So I need to get this right here, this n squared. I need to get this all by itself. So the first thing I'm going to do is add 2 to both sides. Okay, still trying to isolate, so I want to divide by 100. This is going to cancel off, so I end up with n squared equals 81 over 100. Okay, so I've isolated my variable that's being squared. The next thing you're going to do is take the square root of both sides because you want to undo the power of 2. These things are inverse operations. Raising something to the second power and taking the square root, those things undo each other just like addition and subtraction undo each other. So if you do it to one side, you want to do it to the other. So then I get n equals plus or minus. The square root of 81 is 9, and the square root of 100 is 10. So plus or minus 9 over 10. Okay, the reason we need the plus or minus is because anytime you have an x squared equal to a number, we'll just go ahead and use 81. This is not asking what's the square root of 81. It's basically asking what can I square to get the number 81. So basically, what could I have plugged in here to make this a true statement? Well, if you do 9 times 9, you get a positive 81. If you do negative 9 times negative 9, you also get a positive 81. So that's why when I go to take the square root of both sides here, it's not asking just what's the square root of 81. It's asking what could I have plugged in for x squared and gotten 81. So it could have been positive 9 or it could have been negative 9. So that's why we always have to say x equals plus or minus whatever the answer is. Okay. If you want to pause your video and go ahead and try this one. Okay, so again, just follow your steps for solving equations. You want to isolate x squared. So you want to get just this all by itself first. So add 8 to both sides. Divide both sides by 36. Okay, so those are both even. I see that they'll probably reduce, but I also see that they're both perfect squares. So I'm going to take the square root before I reduce that. So take the square root of both sides. The square root of x squared is just x. Put your plus or minus there because we always are going to have plus or minus in front of our answers. So x equals plus or minus. The square root of 64 is 8. The square root of 36 is 6. And since these are both even, I'm going to go ahead and reduce it, divide them both by 2. So x equals plus or minus 4/3. Okay, here's another one. Isolate v squared. Add 2 to both sides. Divide both sides by 8. Okay, if you want to reduce that, you can. See if 8 goes into 576, first of all. 576 divided by 8, that gives us 72. So v squared equals 72. Okay, so now I'm going to take the square root of both sides here. Now, if you have a list of perfect squares and you look at that list, 72 is not on that list. So this is plus or minus v equals plus or minus the square root of 72. So 72, you want to look for a perfect square that divides into it. It's not a perfect square itself, but a perfect square might go into it. If you are having trouble finding the perfect square that goes into it, we can go ahead and make a factor tree. So, and you always want to start off with your smallest prime number, which is 2. I see that 72 is even, so I can definitely divide it by 2. So I get 2 and 36. 36 is still even. So 2 and 18, still even. 2 and 9. 9 is not divisible by 2 anymore, so I'm going to go to the next prime number, which is 3. And 3 times 3 gives me 9. Okay, so you want to take pairs of numbers. So I have a 2, which means I can put a 2 out in front of my square root. I have a pair of 3's, so that means I can bring out a 3 in front of my square root. And then I have this 2 that doesn't match up with anything, so that's going to have to stay underneath my square root. All right, and then the last thing you want to do is go ahead and simplify this right here. Go ahead and multiply your 2 times 3. So v equals plus or minus 6 square roots of 2. Okay. You guys try one. Pause your video, try it on your own. Okay, so isolate your k squared. Subtract 7. I'll just double check myself. Okay, divide by 9. K squared equals 11, because 99 divided by 9 is 11. Take the square root of both sides. So k equals plus or minus the square root of 11. And then, since 11 is not a perfect square, you want to think about if you could break that down any further. 11 is a prime number, so it does not break down. That's your answer. All right, I have one more example for you just in case you run into a situation like this. So again, just isolating my k squared. I want to get rid of the 7 first, so I want to subtract it from both sides. Divide both sides by -5. So this is going to give me positive 17 over 5. And then we want to take the square root of both sides. So take the square root of k squared, take the square root of 17/5. So the left side is going to give me just my k plus or minus. So when you take the square root of a fraction, just think about them numerator, denominator separately. The square root of 17, well, 17 is prime, you can't take the square root of it. The square root of 5, 5 is also prime, you can't take the square root of it. So that's my answer, but the form is not good because I have this radical in the bottom. So you just want to multiply top and bottom by the square root of 5. Okay, so 17 times 5 is going to give me 85. So they're both under a square root. So is the 85. And then when I do the square root of 5 times the square root of 5, I get the square root of 25, which is just the number 5. 85 does not have any perfect squares in it. If you make a factor tree, you'll find that there are no perfect squares in it. There are no pairs of numbers. So your final answer is just plus or minus square root of 85 over 5. Okay, email me if you have questions. Have a nice day.